Alright, so this video is going to cover dividing polynomials, and it's going to throw all three ways we've learned into this one video. Now, this is a really good video for you to get the problem, work it on your own, and then compare to what I do so you can see where your mistakes are being made and fix those. So the first way that we covered was dividing by a monomial, and what a monomial is just one term. So if you have a problem and it's divided by x, divided by 9x to the fifth, that's one term. You can use this dividing by a monomial. The second way we talked about was long division, which was the longer process, and this is one that can work in any situation with these polynomials. And the third one was synthetic division. It kind of went along with long division. There was a certain stipulation you had to have, though, in order to use synthetic division. With synthetic division, you actually have to set your divisor equal to 0 and solve it for the variable. When you solve it, if you get a whole number, positive or negative, that tells you that you can use synthetic division. If you don't, then you're going to have to go back and you're going to have to use long division. Alright, so the first dividing example we're going to do is 18r to the 5th plus 36r to the 4th plus 27r cubed, all divided by 9r. So what we first have to do is decide which of the dividing methods we're using. When I look at my divisor here, I see that it's only one term. It's just 9r. So I'm going to go ahead and use dividing by a monomial. In order to do that, I take all of the terms I have in front. So 18r to the 5th plus 36r to the 4th plus 27r cubed. And all I did was I rewrote it. I now need to rewrite my division symbol as a fraction bar. And then I take that monomial, that 9r, and I write it on all three bottoms of the fractions. I'm going to go ahead and I'm going to reduce my coefficients first. So 18 over 9, I can divide both of them by 9. When I do that on the top, 18 divided by 9 leaves me with 2. I still have that r to the 5th over 9 divided by 9 leaves me with 1. So if you want to write 1r, you can, or you can just write r. I'm going to move on to that second fraction. 36 and 9 I need to reduce. I divide them both by 9 again. And I'm left with 4r to the 4th over r again. And I do the same thing with the third fraction, and that leaves me with 3r cubed over r. So I always go through and reduce the coefficients. If you can do both of these steps in one, you're more than welcome to. The next thing I'm going to do is deal with the actual variables and their exponents. So we are dividing here, which means we are going to subtract the exponents. So I don't do anything with the coefficient out front, which is 2, but r to the 5th divided by r, you need to remember on each of these r's, they do have an exponent of 1. So we just subtract those exponents, and I'm left with r to the 4th plus, you have 4. R to the 4th divided by r, we subtract again, we have r to the 3rd plus 3. R cubed divided by r, subtract, and we get r squared. I can't combine these any further, so this would be your actual final answer of 18r to the 5th plus 36r to the 4th plus 27r cubed divided by 9r. Remember that your answer for a division problem is also called the quotient. That's a super important vocab term that you need to know. So the second example is 2n cubed plus 20n squared plus n all over 10n squared. So again, this is written a little different. It's written as a fraction, but all a fraction is a division problem. If I look at what I'm dividing by, it's 10n squared, and this is all just one term. So again, this is another monomial. So I'm taking each of my top terms, 2n cubed, and writing it over 10n squared. I have plus 20n squared over 10n squared, and then finally plus n over 10n squared. I'm going to fill in one missing piece of information here. On the third set, the third fraction, there's no coefficient in front of the n, so I'm going to go ahead and write a 1 just in case you forgot. Now I'm going to reduce all my coefficients first. So in my first fraction, I have 2 and 10. I can divide them both by 2. So on the top, when I do 2n cubed divided by 2, I get n cubed over 10n squared. 10 divided by 2 gives me 5, and I still have that n squared. My second fraction, I have 20 and 10. I'm going to divide them both by 10. So 20 divided by 10 leaves me with 2, and I have n squared over 10 divided by 10 leaves me with 1, and I just have n squared. And on the last one, I have 1 and 10. Now, I can't divide 1 by anything else by itself, so the last fraction just stays as n over n, 10n squared. Sorry. I've dealt with the coefficients, so now it's the exponent's turn. I have n cubed divided by 5n squared. Remember, we subtract those exponents. So I have 3 minus 2, which leaves me with 1, so n to the first. I didn't do anything with that 5, so it's going to stay on the bottom. Plus, here in this situation, you have n squared divided by n squared. When you have anything divided by itself, it just goes away. So I have plus 2. And then on the third fraction, you have n divided by n squared. So remember, it has the exponent of 1, and we would subtract them, 1 minus 2. So I would actually have plus n to the negative 1 over 10. Now I reduced the coefficients, I reduced the exponents, but I do have a negative exponent, and you can't leave it like that. You need to still remember your exponent rules. So I still have n over 5 plus 2, plus that n to the negative 1 needs to move to the bottom to turn positive, which means there's nothing in the top of our fraction. So you have to put a 1 there over, it's now 10n. It moved to the bottom, and it lost its negative sign in the exponent. So this right here would be your final answer. So here's number 3. I look at what I'm dividing by, and it's x plus 9. There's actually 2 terms. There's the x and then the 9. So that means I'm not dividing by a monomial. So I have 2 options, long division and synthetic division. I'm actually going to go through and I'm going to do it both ways so you can see that in this situation, it does get us to the same answer. So in order to even see if we can do synthetic, I take what I'm dividing by, I set it equal to 0, and then I solve. So I subtract 9 from both sides, and I get x is equal to negative 9. This right here, since it's a whole number, tells me that I could use synthetic division if I wanted to. We're going to go ahead and start with the long division though. So on the outside, you have what you're dividing by, which is x plus 9. And underneath your division symbol, you have x cubed plus 10x squared plus 13x plus 36. So when you did long division before with numbers, like if you had 3 divided by 16, you'd first ask yourself how many times does 3 go into 16, which is 5. Then you would take 5 times 3. That would give you 15 down here. You would subtract it, and then you would get a remainder of 1. Our long division with polynomials follows the same process. I'm going to start with this x, and you need to ask yourself, what do you multiply x by to get x cubed? And that would be x squared. So just like we did in our number example, I now multiply this x squared, but I'm going to multiply it by everything. So x squared times x gives me x cubed, and then x squared times 9 gives me that plus 9x squared. When we did it with our number, we had to subtract, and that's what you have to do here. So you're going to put some parentheses around what you just got, and you need to remember there's a minus sign on the outside. That minus sign gets distributed into parentheses, so it changes the signs of what's in parentheses. And now we just have a big addition problem. I do x cubed minus x cubed. That just cancels out. It goes away. And that's what you have to do each time. If your first term doesn't cancel out, you've done something wrong. Now I have 10x squared minus 9x squared, and that leaves me with a 1x squared. And I drop down my next term. So I have x squared plus 13x. And now you're just going to repeat the process again. I ask myself, how do I turn x into x squared? What do I multiply it by? And that's a positive x. And I'm now going to multiply that positive x by everything over here. So x times x gives me x squared. X times 9 gives me a positive 9x. I go ahead and put my parenthesis around that and the minus sign on the outside. So my signs inside change. And you have your addition problem. I have x squared plus a negative x squared, or x squared minus x squared, and that cancels out. And then I have 13x minus 9x, which leaves me with a 4x. I'm going to go ahead and drop down my next term, which is a plus 36. And again, I'm going to ask myself, what do I multiply x by to get 4x? That ends up being a positive 4. I have to multiply that positive 4 by x and by 9. When I do that, I end up with 4x plus 36. Put your parentheses, your minus sign, change your signs. And then I have 4x minus 4x, which cancels out. And then 36 minus 36, which cancels out. So ultimately, at the end, I'm left with 0. If you have 0 at the end, this tells you that there is no remainder. That tells me that x plus 9 went into that nicely, and so my quotient ends up just being this x squared plus x plus 4. There's no remainder. That would be your answer. So we're going to do the same exact problem but with synthetic division so I can show you that it works out the same. So I earlier found this x equals negative 9. I'm going to take that number, negative 9, and it's kind of going to go over here in this little house by itself. Now, when I look over at my problem, my highest degree is x cubed. I'm going to take the coefficient from that, and it goes next. My next highest degree is x squared, so I have 10x squared. Its coefficient is 10. Then I deal with my x term, which is 13x. Its coefficient is 13. And finally, the constant by itself is 36. So this is how you get all those numbers for synthetic division. And now we start the process. I'm always going to drop this first number down, which is 1. Now I'm going to take whatever's in this little house and multiply it by these numbers down here. So negative 9 times 1 gives me negative 9. And that's what goes under the next coefficient. Now we just treat this exactly what it looks like. This is going to be 10 plus negative 9 or 10 minus 9, which is going to give me 1. And I multiply it again. Negative 9 times 1 gives me negative 9, so it goes underneath the 13 now. I go ahead and add 13 and negative 9 together, and that gives me 4. We're going to multiply 4 times negative 9 and get negative 36. And then finally, we're going to add these together, 36 plus negative 36, and that gives me 0. And I'm going to put a little box around that again. That last number that you got there is your remainder. So I know here I don't have a remainder, which is what I found out with long division as well. Even though I have these numbers, I'm not done. This isn't my answer. So I need to write my answer, and you write your answer using these numbers on the bottom row, the 1, 1, 4, and 0. So I start with that first number, which is 1, and I look at my original problem, which started with an x cubed, so I go 1 degree less than that. These numbers on this bottom row are the coefficients in front of the variables. I just told you we're starting with 1 degree less than to the third, which would be squared or 2. So I have 1x squared plus 1x plus 4. Now, since there's no remainder, I don't have anything else. And if you look, our answer we got with synthetic division is the same exact answer we got with long division. So that's how you know both of these work, as long as when you set your divisor equal to 0 and solve, it gives you a whole number. So the fourth and final problem we're going to do is 90r cubed plus 145r squared plus 77r plus 29, all divided by 9r plus 10. Now, first things first, I need to check to see if I can use synthetic because it may save us some time. So 9r plus 10 is equal to 0, 9r is equal to negative 10, and r is equal to negative 10 over 9. This is not a whole number, so we cannot use synthetic division in this case. Alright, so I'm going to go ahead and set up my problem for long division. That 9r plus 10 is going to be on the outside. And on the inside of my division problem, I'm going to have 90r cubed plus 145r squared plus 77r plus 29. Now, how do I turn 9r into 90r cubed? I multiply it by 10r squared. When you multiply it out, you end up getting 90r cubed plus 100r squared. Again, we put parentheses around it with our minus signs. So I have minus and minus. I'm going to perform that addition problem. That ends up canceling out our first terms. And then I have 145r squared minus 100r squared, which leaves me with 45r squared. Now I need another term, so I drop down that plus 77r, and I repeat the process again. I want to turn 9r into 45r squared, and I'm going to do that by multiplying it by a positive 5r. I'm going to multiply everything out, and I get 45r squared plus 50r. Again, we have the parentheses with the minus signs, change our signs inside, and then we add. Our 45r squareds cancel out, and I have 77r minus 50r, which leaves me with 27r. Drop down that plus 29, and to turn 9r into 27r, I'm going to multiply it by a positive 3. So then I end up with 27r plus 30. My last time, I'm going to put the parentheses around with the minus signs. When I cancel out 27 minus 27r, they go away. But I have 29 minus 30, which leaves me with a negative 1. Now, just like in synthetic division, whatever number you have last down here tells you whether or not you have a remainder. And since we have something there, we do. So I'm going to take whatever sign it has. So since this is negative, after my last term on top, I'm going to put a minus sign. I'm going to put whatever number it was, so it's a 1, and I'm going to put it over what I divided by. So you can either get it from here or in the original problem. And on the bottom, it just is 9r plus 10. So when you have a remainder, you just write it over whatever you divided by as a fraction. So our actual quotient for this problem, or our actual answer, would be this entire part here with the remainder.